Hi there, folks. Hope you're all doing well and you're ready for question 20 on our 2010 Pascal math contest. The odd integers from 5 to 21 are used to build a 3x3 magic square. In a magic square, in case you don't know, they do pop up from time to time on contests. The numbers in each row, column, and each of these main diagonals have the same sum. Okay, this is your basic magic square. You can have other ones where the product in every row, column, and diagonal is the same, or other such things. You can get what are called geometric magic squares, and there's some nifty stuff out there, but we're not really going to get into it. Just a simple Pascal question. If 5, 9, and 17 are placed as shown, what is the value of x? Okay. So, depending on your familiarity with magic squares, you might be able to fill in a few things. You might be able to fill in the middle square just knowing the range of numbers that we're talking about. Okay, it's always going to be the middle of your numbers. So from 5 to 20, it's going to be 13 in the middle. Now, of course, you didn't need to know that it's always the average of your range of numbers goes in the middle of a 3x3 magic square because, well, we can do a little more reasoning and probably work out a few things. But, yeah, let's copy this down into our notebook. Let's get question 19 out of the way. And we'll just draw a big 3x3 grid. So we've got 5 up here, 17 here, and 9 here. And I just want to know what is x. Okay? What is x? So, what can we do here? Well, I'd really like to see. The problem here is I don't have enough information to fill out one of these exactly. But there are things we can do. Usually the first thing I do with a magic square, if I'm not using any of the fancy tricks, is I just try and figure out what should be that same sum. Every row, column, and diagonal has the same sum. What should it be? So if I were to add up these 3 squares, I'd get my sum of, let's call it s. Then if I were to add up the next row, I don't know what the numbers are, but I do know they have to add up to the same thing, s. Same with this bottom row that has x. I would like to figure out what x is, but they all add up to s. So all the numbers, each number here has been, even though I don't know which number is which, each number has been added once. So the sum of all the numbers is 3s. So that's going to be 5 plus 7 plus 9, because they told us it's just the odd numbers. 19 and then 21. So if we just add those up, 12 and 20 is 32. 17 and 13 make it 62. 19 and 21 make it 102. And we get 117. So 3s is 117. Divide that by 3, and you're going to get 39. You're going to get 39. So the sum in each row and column and diagonal must be 39. Okay, useful information. And so now I can start targeting parts of the structure. I can figure out the center. Now, I already explained that there is a trick that it's always the middle number of your sequence. And you're welcome to show that on your own. And if you knew that, of course, you're going to fill in 13 right away. But now that we've figured out, and I've shown how to figure out this common sum, well, we can say things like 9 plus that middle number plus 17 is 39. Rearrange, and the box here is going to be 39 minus 9, which is 30, minus 17, 13. So 13 really does go in the middle here. Similarly, we can now figure out the one right below. So 5 plus 13 is 18. What more do I need to make 39? 21. Okay. So we start filling out things like that. Okay, now I want this x here. And I try and think of ways to figure out what x could be or should be. And, well, this 21 is kind of a big number. X plus 21 needs to be 39. Well, 39 minus 21 is going to be 18, right? So x plus this y over here needs to be 18. Okay. Similarly, so what does that tell me? Well, it tells me x is no bigger than 18. So what could x be? X can't be 17. That's already picked. It can't be 5. It can't be 9. X could be 7, could be 11, could be 15, and that's about it. Those are our possibilities. Now, let's focus on this 9 right here. Again, 39 minus 9 is 30, and so these two numbers have to add up to 30. Okay? So what numbers can go in this box here? Well, it can't be 5. 5's already taken. 7, certainly. Could be a 7. It can't be a 9. It could be an 11. Could be a 15. That's not taken. Or it could be a 19. Right? Now, that plus x must be 30. So if x were 7, if I call this guy y would have to be, in order to add up to 30, it would have to be 23. Well, that doesn't work. And if x were 15, well, y would have to be 15, but then I've used the same number twice, so that's not going to work. Okay? But if x were 11, then y could be 19, and that does work out, and that you can see that's the only one that's going to work out. So x is indeed 11. Okay, and we can even fill in the rest of this thing right here. Oh, I already had a y over there. Should have called that z, I guess. But we get 11, we get 19. This will be 7 down here. And we're missing 1. This will be 15 up here. Okay? So it's not the only way to do the question, but it certainly gets the job done. So our answer is 11, and that's going to be B. Okay? Just as another comment, because magic squares, they pop up on the earlier multiple choice contests from time to time. Just as a little comment, our general magic square with the numbers 1, 2, 3, 4, 5, and all the 3x3 magic squares are basically just some variation of this. Okay? Where you don't view it so much as 1 and 9, but as the biggest number and the biggest number and the smallest number, or the middle number and things like that. And 5, the middle number is always in the middle. Okay? And then if you think about it, well, what possible sums could I have? The sum is always going to be 3 times the middle number. So we need sums of 15. And you might think, okay, where could this 9 be placed? This biggest possible number. Could it be in a corner? Could it be on the side? Now, we saw 21 is placed on the side. 21 will the biggest number will always be on a side. It'll never be in a corner. Why is that? Well, if I've got 9 in the sum, I could have 9 plus 5 plus 1. Or I could have 9 plus 4 plus 2. I can't have 9 plus 3 plus 3. That'd be using the 3 2 times. We only have 2 possible sums involving 9 that equal 15. But if 9 were placed in a corner, I'd need 1, 2, 3 sums that equal 9. And there just aren't any. Okay, so little observations, and knowing the 3x3 and even the 4x4 for harder questions can really help you out. Opposite the biggest number will be the smallest number for similar reasons. There's only 2 sums that involve 1. Okay, if we continue to look at things like, well, how many, where could the 3 be? So we can have 3, 5, and 7. You just need to look for ways to make 12. You can't have 3, 6, and 6, but you could have 3, 4, and 8. And that's about it there. So, okay, we don't have many ways that we can make 3. So 3's got to go on a side as well. Okay. And opposite the 3 would have to be 7. So, you can put the 3 on the right and the 7 on the left, or you could swap them. It's symmetric at this point. But then you start to think, well, where could the 2 go? Okay. So we'd have 2 here, and 2 could go with 4 and 9. Well, that's the other one involving 9. Now, if I put the 2 here, 2 and 3, I'd need a 10 here. Well, that's no good, so I've got to have the 4 here. And this is the sort of reasoning we were doing. The 2's got to go here, the 6 will go here, and the 8 will go here, and the whole thing fills out. But a really nice way to figure out where do things go is to figure out what sums could I possibly have? So that's a little bit about magic squares and how they're in general put together. At least the 3x3 case. Similar analysis works for some of the odd ones. Even magic squares are an interesting thing unto themselves. But I think the video's dragged on long enough as is, so I'm going to let you go there. And I will see you, if you would like to, for question 21 in the next video. Take care.